Good morning, everyone. This is exercise 10H. Currently for me, it's the 6th of April. It's Monday of the last week of term. And it's a bit cold. And it's weird being inside all the time. And not watching Netflix all the time. So, we're looking at the last exercise in chapter 10. We've skipped exercise 10G because it uses some calculus differentiation that we haven't learnt. And we're not learning till much later in the year, so we'll come back to that. But now we're going to have a look at geometry using polynomial techniques. And the main word I'd like you to look at right now is this word tangent. We have come across this before. Last year when we were doing circle theorems, we had a circle and we had like the midpoint of a circle, and we had a line going along the circle. Hang on, let me make this an actual line. But it didn't cut across and it didn't miss it. It hit it exactly once. And we discovered that that line from, that tangent and the midpoint, they were perpendicular with each other. Now we're going to be using something fairly similar in this chapter, but it's not circles. It's going to be usually quadratics. So if I had just like your general quadratic like that, let me draw a good one. So here's my axis. And I've just got the basic quadratic y equals x squared. So it's going to go through 0, -1. Oh, let me actually draw well. So it's going to go through these points. Okay, like that. Same on this side. Same on this side. Like that. And it's like rounded there. And when I say I'm looking at a tangent to this, that means I've got a line that's hitting this. Again, it's not cutting through it, and it's not completely missing it. It's touching it. It's not cutting through, it's not missing, it's touching it at exactly one point. And if I'd drawn this with like finer pens, you would see that that's only 1 point. That's touching that. And if I decided that point, I don't actually know that point, but if that was like 1.2 comma 1 point, what's 1.2 squared? I need a calculator. I'm not awake enough. 1.44. So that's tangent at the point 1.2, 1.44. So what we're doing is we're finding stuff out about tangents. Also midpoints, midpoints. We've done a lot with midpoints. So for example, if I had another thing cutting across here and I was looking at the midpoint between where it intersects, then this would be the midpoint. Well, would that be the midpoint? Let's look a bit closer. Then like this would be the midpoint. So that's what we're looking at today. The best way to kind of get to know these is to have a look at some examples. So I'm looking at worked example 20 from the textbook. They say we've got the line y equals 2x, and we've got the parabola y equals x squared, take 2x, take 8. I'm going to factorize that because it's a lot easier to sketch these when they're factorized. Y equals x squared, take 2x, take 8. I'm factorizing it just because that's the best way for me to find the zeros, the x-intercepts, rather than having to use the quadratic formula. What times is together to give -8, that adds together to give -2. We've got x take 4, x plus 2. So if I wanted to sketch these two, and again, we never bother doing an amazing job of these. So this is y, x take 4, x plus 2, so it has intercepts at +4 and -2. So it's going to look like that-ish. I'm not going to find any other information out about it. So that's my y equals x squared take 2x take 8. We've also got the line y equals 2x. So that's a straight line, hasn't been moved up or down going through the origin. It's got a gradient 2, so it's going to go up 2 for every one it goes across, down 2 for every one it goes across. It looks like that. So I've got those two lines. Meets at the 2 points. So if I'd continued this one going up, then this one nope, wrong colour. There we are. Would have met there. So I'm really regretting doing this whole thing so small. Let me move it down so I can see more of it. So if I kept this one going up and this one going across, it'd be like there. So we've got 2 points of intersection here. This point and this point. Don't bother measuring it. I did not draw it accurately. I'm going to call this point, like you don't know which points A and B, like A and what else, other colour, B. You don't know which points which. We're just going to generically decide so that this is point A, alpha, comma, 2 alpha. So whatever alpha ends up being, then the x coordinate is alpha and the y coordinate is twice that. And we knew it would be twice that, firstly because they told us, and secondly because it's on the line y equals 2x, so whatever x is, y is double it. And this is the point B, which is beta, comma, 2 beta, not alpha. Okay. Show that alpha and beta are the roots and hence of this different one, and hence find the coordinates of the midpoint AB. I said then, like I knew what was going on. It sounded convincing, didn't it? It was pretty good. So, what they mean is, if we've got y equals x squared, take 2x, take 8, and y equals 2x, then we can say 2x equals x squared, take 2x, take 8. And what we're trying to find is the value of values, we're going to end up with two of them, of x for which this works. So we're going to end up with 0 equals x squared minus 4x, because we just subtracted that 2x, take 8. Okay, so we're there. Now, show that alpha and beta are roots of this, so, and hence find the coordinates of the midpoint. So then, so the roots, don't forget, if I've got, I'm going to do this in red, y equals ax squared plus bx plus c, with zeros, alpha and beta, then alpha plus beta equals minus b on a, and alpha times beta equals c on a. I hope I've remembered that correctly. I think I have. Which means, and these roots are literally the values of x for which this happens, which is going to be alpha and is going to be beta. So, we can now say alpha plus beta equals minus negative 4 on 1 for our example, which is 4. And we also know alpha times beta equals c on 1, which is negative 8 on 1, which is just negative 8, yeah?